If you've built or studied retrieval-augmented generation pipelines lately, you've probably seen the same pattern. You run retrieved passages through a stronger language model to rewrite or compile them, feed that into a smaller reader, and suddenly your token-level F1 score jumps by tens of points. The standard explanation is straightforward. The rewriter is doing heavy lifting, denoising, organizing evidence, chaining multi-hop facts. But what if that lift isn't coming from better curation at all? What if it's just because the gold answer string got quietly surfaced in the rewritten context? This is the exact question a recent study from Ant Group set out to answer. In multi-hop QA benchmarks, rewriters surface the correct answer in roughly 80% of cases. That creates what the authors call observational entanglement. You can't tell if the performance gain comes from the rewriter actually understanding and restructuring the evidence, or if it's just handing the reader a cheat sheet. The field's usual fix for this is substring masking. You replace the gold answer with a sentinel token, usually, and rerun the reader. If the score collapses to baseline, you call it answer leakage. If it stays high, you call it a non-leakage channel. But this paper shows that single sentinel masking is fundamentally fragile. On the 2-wiki multi-hop QA dataset, the probe leaves a positive 4.12 F1 residual that looks like genuine curation. Swap it out for 4 alternative sentinels, and that residual flips negative, ranging from negative 3.33 to negative 7.81. You're not measuring curation quality, you're measuring a token artifact. The token itself carries structural priors and formatting expectations that the reader exploits, making it an unreliable diagnostic tool. To break this entanglement cleanly, the authors designed a controlled intervention audit. Instead of relying on a single masking probe, they apply 4 precise edits to every rewritten context and measure the causal impact on reader F1. First, they remove the gold answer span entirely. Second, they replace a length-matched random non-answer span as a placebo. Third, they prepend the gold answer to rewrites that originally lacked it. Fourth, they insert it at a midpoint sentence boundary. They stratify every record based on 2 binary flags, whether the answer was already in the raw retrieval and whether it appears in the compiled output. This lets them isolate the exact causal effect of answer presence. The key technical move is the causal contrast. By subtracting the placebo delta from the removed delta, they cancel out the generic penalty of deleting text and isolate the true cost of removing the gold answer string. The results are stark. Across 12 different reader compiler dataset combinations, removing the gold answer drops reader F1 by 28 to 64 points beyond the length-matched placebo. That's not a marginal effect. It's the dominant driver of performance. When they tested insertion, prepending the gold answer to rewrites that missed it recovered between 0.7 and 9.7 F1 points in 10 out of 12 cases. But here's the nuance. Injecting that same string at a midpoint boundary mostly failed to recover performance. The reader is highly position-sensitive. It trusts information at the very beginning of the compiled context, but largely ignores it when it's buried in the middle. This aligns with known long-context limitations, where models disproportionately attend to prefix information. Let's unpack what this means technically. The authors aren't saying rewriters don't do anything useful. They acknowledge that curation and denoising likely play a role, but they bound how much of the lift can credibly be attributed to that. If removing the gold answer costs you 30 to 60 F1 points, then most of the reported gain in compile-then-read RAG pipelines is causally dependent on answer surfacing. This also explains why verification modes and stronger rewriters don't automatically solve the problem. The issue isn't just rewriter capacity, it's the structural reliance on the reader scanning for the exact answer string. Furthermore, the sentinel fragility finding is a methodological wake-up call. If your diagnostic tool changes sign based on whether you use or a natural language deletion phrase, you don't have a reliable leakage detector. You have a prompt sensitivity artifact. The takeaway for anyone building or evaluating RAG systems is clear. If you want to claim that your rewriter improves evidence quality independent of answer leakage, you need a paired remove versus placebo audit, not just a single sentinel mask. The authors have open-sourced their intervention runner and sentinel panel, so the community can standardize this evaluation. As RAG pipelines get more complex, we need to stop conflating surface-level string presence with genuine reasoning. Rigorous, controlled interventions are the only way to separate signal from artifact. If you're working with multi-hop QA or long-context retrieval, I'd strongly recommend looking into their audit kit and running these contrasts yourself. The field is moving fast, and the next step in RAG evaluation isn't just bigger models, it's sharper diagnostics. Thanks for watching.